Today I'd like to show you a memory trick that's been used by many chemistry students and is borrowed from the ancient Roman senators who used to give ridiculously long speeches without any sort of cue cards or teleprompters or anything. So what they would use for their speeches, they would memorize the introduction to their speech and the first part, second part, and third part in different rooms of their house. And then they would imagine themselves in those rooms of their house, and that would click into their brains what they needed to say next. So we're going to use that technique with something called the mole house. Let me show you what I mean. If you look at the sample problem, you know we've got methane gas reacting with O2, becoming carbon dioxide and water. And we need a balanced equation, so because there's 4 hydrogens, we need a 2 there. And now we've got 4 oxygens total, so we need a 2 there. So it's a 1 to 2 to 1 to 2 ratio, and that works with moles. So if we want to know how many grams of H2O you could make with 7 grams of CH4, we first have to change from grams to moles, and then we can use the balanced equation. So what we're used to doing is saying we would have 7.00 grams of CH4, and then to change to moles, we'd say that 1 mole of CH4, and then we'd go to the periodic table to figure out how many grams 1 mole of CH4 is. From the periodic table, it says that carbon is 12.01 grams for every mole. If you have 4 hydrogens, that's 4 times 1.01, so 4.04. And we know that CH4 then is 16.05 grams for every mole. So we would say that 7 grams of CH4 times 1 mole of CH4 over 16.05 grams of CH4 would give us moles of CH4. But what the Romans would think, well, what we're borrowing from the Roman idea, they'd say, let's say you're starting out with your 7 grams of CH4. That's like a room. And that's a room of grams. And for all of these equations, we're starting with one kind of molecule and changing to a different kind of molecule. So I'm going to say this is the first kind of molecule, or grams. I'm going to say the first kind of molecule is A, and then the second kind of molecule will always be B. So they would say, we're starting with grams of one thing, we just changed to moles of that. So let's say that we've gone from one room to another room, and the name of this room is moles of A. Now to get from that, we use the balanced equation. So it's kind of like, we used the periodic table, and we said that CH4 was 16.05 grams per mole because of the numbers on the periodic table. So I'm going to say the door that we walked through was PT for periodic table. So they would say we've gone from grams of CH4 to moles of CH4. Well, now we can use the balanced equation because our goal is grams of H2O. We can say that 1 mole of CH4 will produce 2 moles of H2O. So we would say 1 mole of CH4 produces 2 moles of H2O. That's like going to another room. So we've got another room. Only this room is moles of the second thing, which we're going to call B. So water is B. Now to get from moles of A to moles of B, we used the balanced equation. And so I'm going to say BE for balanced equation is the door from moles of the first thing to moles of the second thing. We want to find grams of the second thing. So 1 more door and 1 more room, but this will be grams of B. So we say, from what we're used to, that, okay, our grams of CH4 have canceled, our moles of CH4 is canceled. Now we're going to say that 1 mole of H2O is 18.02 grams of H2O. I'm assuming you know that one. So that's, once again, going from one room to another. We've gone from moles of water to grams of water, and that used the periodic table again, because adding up water, 16.00 plus 2.02 gave us the 18.02 grams. That got us to grams of B. or grams of water. Now you work this through on your calculator and you'll get 15.7 grams of H2O. So we start in one room, go from grams to moles, and then from moles to moles using the balanced equation, and then from moles to grams. Well, there's a little more we can do with this. There's a lot more, actually, because we know that now that if you have a gas that you really can't measure the grams of a gas, you work with liters of the gas. So if we had liters of CH4 reacting with liters of O2, the balanced equation still works. We can say 1 liter of CH4 reacts with 2 liters of O2 to produce 1 liter of CO2 plus 2 liters of water vapor. And if we are working with the conditions of standard temperature and pressure, we know how many liters 1 mole of a gas is. So we can say, we got another room, only this is going to be liters of A if it's a gas at STP, standard temperature and pressure, which is 0 degrees C and 1 atmosphere, which is regular sea level pressure. And to get from moles of one thing to liters of that thing, we say there's 22.4 liters is 1 mole. So we can say 22.4 liters is 1 mole. But if we're talking about a new thing, a new molecule, we could do that with that new molecule. So we can say if we know moles of B, we can figure out liters of B if it's a gas at STP. Has to be a gas, but that's 22.4 liters. But the brilliant thing about this is that we've got liters of one thing and liters of another thing. We can go straight from the liters to the liters of A and liters of B, using the balanced equation. So let me show you. Oh, I might as well finish this, because we can say that 1 liter of CH4 would produce 2 liters of H2O. So I can use the balanced equation to go from liters of one thing to liters of the other, as long as they're both gases at STP. So here's how we would use this. Question is, how many liters of carbon dioxide could be made with 8 grams of CH4? So we're starting with grams. We're going to start with grams of the first thing. So 9.00 grams of CH4. But this time, we want to end up in liters of CO2. So liters of the next molecule, which will be B, which is the CO2. So I'm going to start with grams. I got to go to moles. So 1 mole of CH4, we already figured that out, is 16.05. 16.05, hello, grams of CH4. But now we can say we want to find liters of B, and we actually have a choice. We're here, we could go down to liters of CH4, and then from liters of CH4 to liters of CO2, or we can go from moles of CH4 to moles of CO2 down to liters of CO2. And you'll get the same answer either way. I'm going to be consistent. When I have a choice, I'm going to go from moles to moles. But if you want to try it the other way, it works great. So I'm going to say that 1 mole of CH4, and this is from the balanced equation, will produce 1 mole of CO2. So now I've gone from grams to moles to moles. Now I'm going to use the 22.4 liters as a mole to get to liters of B, or liters of the CO2. So keeping track of what's canceled out, 1 mole of CO2 is on the top, so I want my 1 mole of CO2 on the bottom. But now I'm going to say 1 mole of CO2 is 22.4 liters of CO2, because that's true of any gas at STP. So now in my calculator, 9 divided by 16.05 times 22.4, I'll end up with 12.6 liters of CO2. So I've got from grams to moles, moles to moles, moles to liters. If I'd gone grams to moles, moles to liters, liters to liters, it would work great too. All right. There's 2 more rooms we can put on here because we can go from moles to something else, and that's number of molecules. So I'm going to put actually 2 more rooms up here, one for A, one for B, and we'll call this molecules. And it also works for atoms if you have single atom things like sodium or some metal. So we can have molecules or atoms of A, and a room that's molecules or atoms of B. If you think back to the balanced equation, you could say 1 molecule of CH4 plus 2 molecules of O2 produce 1 molecule of CO2 plus 2 molecules of H2O. So I can go from molecules of the first thing to molecules of the second thing, just once again with the balanced equation. But I can also go from molecules of something to moles of that by using the fact that 1 mole is 6.02 times 10 to the 23rd molecules or atoms. So I'm going to say 6.02 as the door here, meaning 6.02 times 10 to the 23rd. But that's a lot to write for 1 door, so we're sort of shortening that. All right, so let's look at number 3 for that. All right, so how many grams of water, so we're looking for grams now, can be made if you start with 4.87 times 10 to the 23rd molecules of CH4. So I'm going to say 4.87 times 10 to the 24th molecules of CH4. And then where am I wanting to go? So I'm starting up here and I'm looking for grams of water. So starting with molecules of CH4, and I have choices. I can go from molecules to molecules down to moles to grams. I'm going to, because I always do this, go from molecules to moles, and then moles to moles, and moles to grams. So I'm going to go from molecules to moles first. I'm going to say 6.02 times 10 to the 23rd times 10 to the 23rd molecules of CH4 is 1 mole of CH4. And I put this on the bottom so my molecules of CH4 will cancel out. All right, so now I'm in the moles room and I'm looking for grams. Now I could go to liters, but I'm looking for grams, so that's where I'll go. So 1 mole of CH4 from the balanced equation will go on the bottom. I'm looking for water, so that's 2 moles of H2O. So now I've just gone from moles of the first thing to moles of the second thing. And then finally, I can go to grams. So 1 mole of H2O is, again, 18.02 grams of H2O. So my moles of CH4 have canceled, my moles of water have canceled, and I've got grams of H2O. So work that through on your calculator and you'll get 292 grams of H2O. All right, so let's try kind of an odd one, this last one. What if you have liters of something and they're all gases at STP, or you want to find molecules of that thing? So we're starting with 65.3 liters. We're starting down here, and we want to go to molecules of the new thing, of CO2. Well, we can do this. So 65.3 liters of CH4. We'll start there. And I'm going to go up to moles. So I'll say that 1 mole of CH4 is 22.4 liters of CH4. So now our liters are canceled. I've got moles of CH4. I'm in the moles room. I'm looking for it to go here. Now I could go up and over or over and up. I don't know if you have any rooms in your houses like this that you can get one place with many different routes, but I'm going to go from moles to moles. So according to the balanced equation, 1 mole of CH4 produces 1 mole of CO2. So 1 mole CH4 produces 1 mole CO2. So now I've gone from moles of the first CH4 to moles of the CO2. Now I'll go up to molecules. These have canceled. So 1 mole of CO2 is the same as, or is equivalent to, or is 6.02 times 10 to the 23rd molecules of CO2. All right, so I know I'm going to do 63.5 divided by 22.4. There's just ones. And then times 6.02 times 10 to the 23rd. And I end up with 1.75 times 10 to the 24th molecules of CO2. So the mole house just lets you go all over the place. Now there's one other kind of problem I want to show you that's a really simple one. And that's just going from one room of the house to the other if they're connected by the balanced equation. We call these one-step problems. So one-step problems. And here's an example. Let's say I had 10 liters of CH4 and I wanted to know how many liters of H2O I could make with that. So if I have 10 liters of CH4 and I wanted to know how many liters of H2O, I can just use, this looks really strange, but I can say that 1 liter of CH4, and this is from the balanced equation, 1 liter of CH4 will produce 2 liters of H2O. And that's all you have to do. So the liters of CH4 cancel, you have liters of H2O, and of course this will just be 20 liters of H2O. So I hope you enjoy a memory trick, and if this does not work for you, if this is not helpful, you absolutely do not have to use it. I will not require it on a test. But if you are thinking Roman, maybe this will help you work through these problems. Have a good day.